Hi, this is Math 7, Unit 6, Lesson 12, solving problems about percent increase or decrease. And so today we're going to be looking at using tape diagrams, equations, and reasonings to solve problems with negatives and with percents. So begin first of all with this little section called 20% off. And so 20% off means that there is a discount that's applied, and that's usually when you get off. So when you have a discount, 20% off, that also means that you're only paying 80% of the original cost. To get that 80%, what we're doing is we're saying, well, the original cost is 100%, and we're taking away 20%, and that leaves us with the 80%. Now these are numbers here, not percentages. So that's what this was over here. It looks like numbers. We want to talk about percents though. And so when we talk about percents, it looks like 100% minus 20% to say we're going to have a total spent of an 80%. But percentages are written in different ways, right? We have to move the decimal over, so we end up with a 1 minus a 0.20 to equal 0.80 there. You end up with like fraction or decimal numbers, or 0.80% when you do 1 minus 0.20. And 80% can also be written as a fraction, 0.80, sorry, which is the same as 80/100ths, like so. And so looking at all that, when we talk about over here, which one of these expressions could represent a 20% discount? Here we have represents the price of an item after the discount. When we're talking about the price of an item after the discount, that is not the discount, that's going to be the 80% of what's left of it, right? So this will be like your sales price. It's 80%, not what is the discount, but what is the price after the discount. So it's so important to read what you're being asked to find out here. So we're looking for that 80% number. So here, this would actually tell me the discount. This would tell me the 20% because 20 divided by 100 is 0.2 or 20%. That's what I would use to find out just the discount. What is the savings going to be? But I want to know the price after the discount. Okay, so over here, for example, this is the 80%. 0.8 is 80%. That one's going to work out well. This is 0.2%. This is 0.8. So these are like the opposites. Here we have an x minus 20 over 100. This is the same as saying 1 times x minus 20 over 100 there. 1 represents that 100%. 100% minus 20%, which is matching right there. So this would work just fine. This is 100% minus 20%, which is still 80%. In number 3, we have 1 minus 0.20. Again, that matches what we have right here, which is still that 80% value. And here on this one, when you have 100 minus 20, that's going to be 80 over 100 and times x, and that's going to match what we have right here, which is also that 80%. So numbers 2, 3, 4, and 5 all are going to work well. 6 won't work. That's just a plain old 80 times x. That will not give us a percentage, and or number. It needs to be a percent times the original cost for it to work. So 6 will not work there. So sometimes it's just good to know what you're dealing with and then look back to see which ones correlate or correspond to what you came up with over here as you work stuff out. Let's take a look over here at number 2, walking more each day. May has started a new exercise program. On the second day, so here's day 1, she walks that far. On the second day, she walks 5 minutes more. So we can see that being added right there, that she does day 1 and she does the same amount plus 5 more minutes right here, right? Plus 5 minutes. On the third day, she increased her walking time from day 2 by 20%. So this right here represents 20%. She increases it by 20% and walked a total of 42. And she drew this diagram to explain how far she walked and show her progress here. So let's take a look at this picture. We know she walks a certain amount on day 1. On day 2, she does that same amount plus 5. And on day 3, she adds this 20%. So I guess what we have to talk about here is where does this 20% number come from and how would you say it's 20? Well, what you might want to look at here is that if I considered this to be 100% of day 2, this value there, right? These squares. I have 1, 2, 3, 4, 5 squares right there. Now 5 squares, if I did 100 divided by 5, that's going to get you 20. which means that each of these represents 20%, 20%, 20%, 20%, 20% all the way through. So this little section is also an additional 20%. These 5 are going to be 100% of day 2, and then we're adding another 20% there. Okay, you can also consider it to be that this one right here, if this is 100, is 1/5, right? It's a 1/5. If this is our 100 mark right there, in 5, it's a 1 out of 5. And 1/5 is the same as 0.20, which is also 20%. So that's where that all comes from. In our next section, it says that Noah said the equation 1.20 times d plus 5 equals 42 represents the situation. Do you agree with what Noah is saying? So Noah says that when we look at this situation here, it's 1.20 times d plus 5 equals 42. Do we agree with that there? So when we look at this, how does he get this 1.20? 1.20 is equivalent to 120%. So when we look at day 3 is 100% of day 2 and another 20%, 120%. So day 3 is 120% of day 2. This is 120% of day 2 equals 42. And so in terms of what this means, is 120 written as 1.20? Sure it is. This is 1.20. And day 2 is simply d plus 5. D plus 5. So those are equivalent things. So we would agree with Noah because day 3 is indeed 120% of day 2, which is d plus 5 there. Some people might say, well, that's not quite it, because when I look at this, it's actually 6 out of 5, right? This is 100% is here. I have 6 out of 5. Well, 6/5 is the same as 1.20. So there's not a major difference there. Just depends if you want to use fractions or decimals. In part 3, it says find the number of minutes May walked on the first day, and then use a diagram, equation, or another strategy. So let's talk about May. So we know she walks 42 miles in total, right? Let's use a diagram here. If she walks 42 miles in total, I'm going to erase these numbers right here real quick, okay? That means in this part here, we can take 42 and we can divide that into 1, 2, 3, 4, 5, 6 sections. So 42 divided by 6 is equal to 7, which means each one of these squares has a value of 7. Now, if that's a value of 7 there, what I know, if this is 7 all the way across, when I look at day 2 stops right here for this many 7s. There are 5 7s. So if I did 7 times 5, that's going to give me day 2, which is going to be 35, right? Because there are 5 7s right there. So this value here is the same as 35. To go back one more step, I need to remove that 5. So if I did 35 minus 5 equals 30, that's going to give me the value for my d, which is right there at 30. So if I use a diagram, I could work my way back to that situation right there. I could also, though, use an equation to solve it if we chose to do that as well. Okay, so a couple different things you could do there. So it depends on what you want to do. If you use the equation that Noah provided, you'd have 1.2 times d plus 5 equals 42. And if you solve that there, you would divide both sides by 1.2. So d plus 5 equals 42 divided by 1.2 is 35. Subtracting 5, you have d equals 30, and you end up at the same spot. So both those solutions work out, both those strategies work out, just depends on, again, what you see and what you wanted to do. Let's look at number 4. It says May has been walking indoors because of cold temperatures. On day 4 at noon, May hears a report that the temperature is only 9 degrees. So it's 9 degrees outside, right? Way to go. She remembers the morning news reporting that the temperature had doubled since midnight and was expected to rise by 15 degrees by noon. So sometime in the morning, she knew that the temperature at midnight had doubled at that time, and it was going to continue to go up by 15 more degrees until it got to noon. And at noon, we said it was 9 degrees. May is pretty sure she can draw a diagram to represent the situation, but isn't sure if the equation 9 equals 15 plus 2t, or 2 times the quantity t plus 15 equals 9, which one she should use. We would say, let's use this one here. Okay, that's because we're going to make sure that all we're doubling is the temperature at midnight, and then we're adding 15 more. If she was to use this one, she's doubling the temperature at midnight, but she's also increasing that by 2 times 15, which is 30 degrees. It was only expected to rise 15 degrees, not 30, so that would be the wrong equation to use there. Okay, so in this case here, we want to make sure we double the midnight and go up by 15 in order to get to 9 degrees total. So what was that temperature at midnight, we might ask? Well, if we subtract 15 from both sides, we have 2x equals 9 minus 15, which is going to be a -6. We divide that by 2, and so our temperature at midnight was -3 degrees. Pretty cold, at least if you're a Californian like we are. Doesn't get that cold over here in California. All right, section 3, sale on shoes. In this next section, we're going to have 4 different questions dealing with some different discounts, and we're going to work through different ways to set up some equations. It says a store is having a sale where all shoes are discounted by 20%. So we know we're dropping the price 20%. Diego has a coupon for $3 off the regular price for one pair of shoes. The store first applies the coupon, then takes 20% off the reduced price. Okay, if Diego pays $18.40 for a pair of shoes, what was the original price before the sale and without the coupon? Okay, so the order here is really important. Okay, there's going to be an original price X. We know that there. The first thing the store does is it applies the coupon. The coupon is $3 off. So whatever the price is, we're going to take off $3. Then, after that's done, so let's put it in parentheses so that it's done first, then it's going to be discounted by 20%. Now I can write this a couple ways. I could write this as 100%, 1.00, minus 20%, right? And that's my discount, 100%, I'm taking 20% off. And when that's all done, he's going to pay $18.40. This then is rewritten as x minus 3 times 80%. Now again, you might have seen that a little faster. You might have said, well, if it's discounted by 20%, 20% off means I'm only paying 80%. And that's how you get that number there. It's 100% minus 20%. And again, that still equals $18.40. So now, to solve this here, I'm going to divide both sides by the 0.80, right? Divide by 0.80. Which leaves me x minus 3 equals 18.4 divided by 0.8 is equal to 23. I'll add 3 to both sides so that x equals 26. So the original price back up here was $26. And so what happened here, Diego had shoes that were $26. They took $3 off to make it $23, and then he paid 80% of that price, for a total of $18.40, and that's what the store price was for those shoes originally. Let's look at a second problem. So before the sale, sorry, I just turned it over first. Before the sale, the store had 100 pairs of flip-flops in stock. After selling some, okay, so they have 100 pairs, and they sell some. After they sell some, they notice that 3/5 of the flip-flops they have left are blue. So after they have 100, they sell some, and 3/5 of what they have are blue. All right, are going to be blue. That's our blue value there. If the store has 39 pairs of blue flip-flops, 39 blue, how many flip-flops of any color have they sold? So they had 100, they sold some, and 3/5 of what they have left equals 39 blue, so what was the number they sold there? And this is our setup for this equation right here. I'm going to multiply by the reciprocal, 5/3, and the reason I'm going to do that is because I know 3 goes into 39, in this case here it goes in there 13 times. 13 times 5 is going to be equal to 65. So now I have 100 minus x equals 65. I'm going to subtract 100 from both sides. So that negative x equals a negative 35. I'll multiply both sides by a negative 1. So that I end up with x equals 35. So how many pairs of flip-flops have they sold? Any color? They have sold 35 flip-flops. Number 3. When the store had sold 2/9 of the boots that were on display, they brought out another 34 pairs from the stockroom. That gave them 174 pairs of boots out. How many were on display originally? Well, be careful with this one here, because we know we're going to be adding 34 pairs to something over here, and we're going to have 174 boots out on display. Now, this number here is going to be multiplied by the number of boots that they had to start with. Okay, so you have to decide, what do I do with this 2/9? 2/9 of the boots. Notice they sold 2/9 of the boots, right? So they had 9/9 and they sold 2/9. How many were left? There would be 7/9 left. So 7/9 of the boots plus 34 more gives you the 174 that are out. This is the key number here that you have to be careful about when you read the equation. It's 7/9 are what are already out there. We sold 2/9. There's 7/9 left. So now we can just solve and we subtract 34 from both sides. So 7/9 x equals 140 multiplied by the reciprocal 9/7. And so that x equals, move this up here, x equals, this reduces there, 1 and 20. And 20 times 9 is 180. So originally there were 180 boots. They sold 2/9 of that, added 34 more, and that got them to 174. So be very careful that you look at the wording here to know what numbers you're going to be utilizing. Okay, and finally number 4, on the morning of the sale, the store donated 50 pairs of shoes to a homeless shelter. Okay, so they had some shoes and they donate or give away 50 pairs of shoes to the shelter. Then they sold 64% of their remaining inventory during the sale. If the store had 288 pairs after donation and sale, how many shoes did they have to start with? So we know they had some shoes, they donate 50. Then they sell 64%, okay, we have another number right here, and we end up with 288 pairs left. Because they sold 64%, how many did they have left already? Well, 100 minus 64 is 36% is what they still had left. 36% as a decimal is 0.36. All right, so now for this number, what we could do is we can multiply, we can distribute if you wanted to, or we can multiply some things out. It depends on how you want to do it. I'm going to go ahead and divide both sides by 0.36. So I have x minus 50 equals 288 divided by 0.36 is actually going to be 800. Then we'll add 50, so that x equals 850. So how many shoes they had to start with? They had 850. So 850, they gave away 50, which gave them 800, and then they sold 64%, which means they had 36% left. That's how they got 288. All right, so that's the idea there with today's lesson. Let's look at our summary statement real quick, just to kind of wrap this one up. And essentially what it says here is that we can solve problems where there is a % increase or decrease by using what we know about equations. So here's another example. A camping store increases the price of a tent by 25%. So there's our increase of 25%. So there's our cost, and we end up with the cost times 0.25. The customer then uses a $10 coupon, right, to take off something there. We're going to get rid of $10. And then pays, here's what's left, $152.50. So you could draw several tape diagrams to show the 25% increase and the $10 off coupon, okay? And we could show that then as an equation to represent that situation could be 125%, which is here, 100% and 25%, of the price minus the $10 is going to equal our total. And that would help us find the original price before the increase and the discount. And we could solve that there to end up that originally it was $132 was the original price of the tent. Let's take a look at today's problems. Number 1. A backpack normally costs $25, but it's on sale for $21. What percentage is the discount? So we had 25 and it went to 21, which means that it went down $4, and it went $4 down out of the original price is 25. So $4 out of $25 becomes 0.16 of the decimal, or in our case here's a percentage, it's a 16% discount, right? Because the original was 25%, that's 100%, minus $21, so that becomes the 16%. Number 2, finding each product here. Just going to do some basic computation. 5 goes into negative 10, negative 2 times. 2 times negative 2 is negative 4. 2 goes into negative 8, negative 4 times. Negative 4 times negative 3 is a positive 12. 6 times 0.6 is actually equal to 6, and 6 over 6 is equal to 1. Negative 100 times negative 0.037 is actually positive 37, still over 37, which equals 1. All right, so that wasn't too complicated, just has to recognize how this works. A 10 times a tenth gets you just the whole number, and 100 times a hundredth gets you another whole number. Number 3, select all expressions that show x increased by 35%. Increased by 35%. So you remember, this is going to be your 100% plus 35%, or 1.0 plus 0.35, or 1.35 is how that all can be written in different ways. This is also going to be 135 over 100 as a decimal there, as a fraction. So an increase by 35%, that's going to be 1.35 times x, that's 135% of the original. This is just a 35%, that won't work. Here we have 1 plus 0.35, that will work just fine because that's 1.0 plus 0.35, the same idea. Here we have 1 plus 0.35 equals x, that will add up to still 1.35. Here we have 135 combined over 100 times x, same idea as there, that works. And this is 135 times x. Not going to work because that's way too big, it should be a decimal, 1.35, so that will not work. So A, C, D, and E are all okay. Number 4, which flips over to the back side, we're going to decide if this is a discount, deposit, or withdrawal. Claire took $20 out of her bank account. She made a withdrawal. That's taking money out. Kieran used a coupon when he bought a pair of shoes. So he used a coupon. He got a discount. If you use a coupon, you get a discount. Parya put $20 into her bank account. She made a deposit. And on the back one more for me. Lynn paid less than usual for a pack of gum because it was on sale. She got a discount. All right, number 5, or I think our last one here for today. We have 2 different stories, one about college freshmen and one about a computer store, computer prices. And for each story, we have 2 different equations that we have to decide which one goes with college, the freshman class, and which one goes to the computer. Okay, and so we're going to figure out what that it's going to be, and then we're going to talk about the parentheses for each one, why one has parentheses, one doesn't, and then we'll solve it and see what you come up with. So here we go. The initial freshman class at a college is 10% smaller than last year's class. All right, so 10% smaller. Last year's class, if it was 100%, and we subtract 10%, it means this year's class is only 90% of the size of last year's class. Or as a decimal, that's 0.90, right, of last year's class. But then during the first week of classes, 20 more students enroll. Okay, and there are 830 kids. So what we know about the freshman class is that you have 0.90% of last year's class plus an extra 20 kids for a total of 830. That's going to be what we have for our freshman class, which matches this equation right there. That's going to be for our freshmen. The next one says a store reduces the price of a computer by $20. You have price of a computer minus $20. Then, that's a key word, during a 10% off sale, a customer pays $830. So, they're going to have 10% off, which means they're paying 90% of the original. Same idea, 10% off means there's 90% left. So 90% of whatever's left equals $830. And that's going to match that one, which is our computer problem. Okay, so we've answered that part there. Why does one have parentheses in it? The reason it has parentheses here in this one is because there's something you have to do first. Before you can take the 10% off, you have to drop the price of the computer by $20. Without the parentheses, the order of operations would be messed up. So you have to make sure that is done first. The store wants the computer to be dropped by $20 first, and then the $10 off. So that then word becomes very critical for our story here. Now let's go ahead and solve each one. We have 0.90x plus 20 equals 830. We subtract 20 from both sides, and we have 0.9x or 0.90x, however you want to do it, equals 810. We divide by 0.9 or 0.90, whatever you want, and x equals 810 divided by 0.9 is equal to 900. So this represents the number of freshmen. Now, that is the number of freshmen last year. Okay, that's what the x stands for, because we're doing 90% of last year. So this is our freshman last year. For the other equation, we have 0.90% times x minus 20 equals 830. And this is going to tell us how many, what the computer cost was at the beginning. So we'll divide by 0.90, divide by 0.90, so x minus 20. In this case here, it's going to be equal to, oh, sorry, did different than my notes. So get my calculator out real quick. 830 divided by 0.9 equals 922.222, just goes on forever and ever and ever. We add 20 to both sides. You end up with x equals 942.2, repeating forever and ever and ever. So the original cost of the computer was $940.22, goes on forever. That's basically it for today. Hope that helps you out, and we'll see you next time.